Well, you know, we have the technology that we didn't have, right? 30 years ago when my house is melted, because I didn't know the building science, right? Maybe some folks did, I certainly didn't. We do know that now. Also, we have this amazing acceleration in computing power. I was thinking about when I started doing CAD, I was on a 286 machine, right? I remember like clicking on a point and getting a cup of coffee while I'm waiting for it to find the point, you know? I mean, it was, it's amazing what we've done. And because of that, all of a sudden we're able to get these great programs that do dynamic analysis in real time and no punch cards, right? So technology has really given us an advantage in terms of designing these high performance buildings. But what we forget is that technology does have a dark side, and that's the important part that we kind of lose sight of, because if you rely too heavily on it without relying on intelligence, you end up with still failures, right? So, you know, I'm really excited about this, right? Obviously, I'm probably sound a little excited. I'm very excited about what we got here, right? And you know, but I know what it's like to be out on the edge, right? So, I want to really be a happy cowboy. I want to go out and sing and dance and tell everybody, passive house, high performance, let's go do it, right? But there are bad cowboys, right? There are people who don't do what they're supposed to do, but still want to tell you about it, right? So there's a lot of work to be done, a lot of shit to be shoveled, so to speak, right? And having gone through the earlier thing that I showed you guys and bared myself, and having done all this kind of goofy stuff, and realizing the pitfalls of doing that stuff, I say to myself, okay, we need to think. We need to stop for a minute, right? We need to think. We need to say, okay, well, yes, this is great news. But the last thing we want to do is start building these things without having a good collegial relationship, building on the knowledge of other people, doing what you do here and in NESI and sharing openly information and systems. There's no commitment of money or anything like that. It's all about making the projects better. It's all about sharing the knowledge and making it better, because you know, in Austria, where they have 6,000 some passive house projects, if they have one or two bad passive houses, no big deal. They can have a whole handful of them, no big deal, because it's just noise, right, in the whole great thing that they're going. But if we get, say, in the next 5 years, 50 passive house commercial projects, and we have one or two that fail miserably because of bad building science, or because somebody didn't think about the occupancy use pattern, or because somebody didn't, you know, change the light bulbs on the drawings, you can about bet in America which one will get the press, right? So what do we need to do, right? What do we need to do to go forward as a group of people who want to push something that's on the cutting edge and not lose our way? So we got to be smart, right? That's it. That's all we got to do. Is we got to be smart about the way we approach things. First thing we got to do is realize that Europe is not the United States. Very first thing. So in Europe, they have a 15 acceptable delta range for thermal comfort, 15 degree F, of thermal comfort between hot and cold. So if it's cool, you put on a sweater. And if it's hot, you take it off, right? So I was in Austria, and I was at this beautiful new passive house school, and huge auditorium kind of, you know, gym, multi-purpose room, and the architect was there, and I said, what do you do? I didn't see any cooling. I saw ventilation, I saw heating, I didn't see any cooling. I said, what do you do in June when the kids graduate and you have all the parents and all the grandparents and all the brothers and sisters, and the kids are graduating, and it's hot. It's 24 degrees out. It's hot in here. You got all those body loads. Oh, if you open the doors, right? It means, okay, so you sweat and you smell each other, right? That's fine in Europe, because that's the cultural expectation. That's not fine in the United States. And especially in the United States, where we expect that in the wintertime, it's going to be 72 degrees. And in the summertime, it's going to be 70 degrees, right? That's what our expectation of comfort is. So if you understand that there's a cultural expectation that has to be changed eventually, but that's not my job to change it now. What I need to do for the first passive houses, for the first projects that we're building, is to make sure that we are overperforming on the thermal comfort for our people, because the last thing we want is for people to go into passive houses who are normal, everyday, not energy geek, low energy nerd people who walk into a passive house and say, oh, it was hot, it was stuffy, it was humid, it was, you know, if you use a 77 degree overheating criteria for passive house, you're not going to have comfortable people in America in a commercial passive house. You can't do it. You got to think about it. So these first group of passive houses, the very first, we're the pioneers. We're plowing the road for all the rest of the folks that are coming after us, right? So we got to make sure that that road is as smooth as we can possibly make it. So when we look at our design criteria for these large commercial spaces where the general public are going to use them, not just energy geeks, right? Then we got to make sure that we're going to meet the thermal comfort expectations of Americans. And not you and me, but like regular Walmart going Americans. Okay? So some other things, right? Europe and the United States, very, very different. Anybody read Latin? Not the heat, it's the humidity. Something they don't deal with. We all deal with here. Well, not everybody, most of us. Also, understanding the way that occupancy use in a building impacts a passive house is huge. In a typical, leaky, crappy American building with a massive mechanical system, the occupants become a very, very small driver of the design, right? In the passive houses, these high-performance buildings, the envelope load is almost neutral. It's compared to the loading potentially of the interior heat gain from people, plugs, and lights. And what happens is you get a completely different scheme that you have to start thinking about because all of a sudden a lot of your heat gain is not just sensible heat, but it's also latent heat. And you've got to deal with that in air times when you're not air conditioning. So there's things going on in a high-performance building of like a passive house that just from the point of view of thinking about how you design your systems and how you make thermal comfort have to be thought about. That's it, they just have to be thought about. They're easy to deal with if you think about it, but you can't not think about it. So, there have been a lot of times when people have come up with really, really good ideas, they thought, and those really, really good ideas turn out to be not so good, right? And what we got to be careful about is the passive house methodology, which has been given to us, right? Where what they've done is taken what we did back in the 70s and 80s and bring that forward into this, into the 20 whatevers in a way that is really well put together, right? The passive house methodology has got a lot of real pluses. The biggest plus to me is that the PHPP is completely open. So you can unlock everything and look at everything, look at all their algorithms and see if you agree with the way they're calculated or disagree. There's tons of stuff in the passive house planning program that I don't agree with, that I change, that I tweak. I'm sure there is for you. I don't know about you, Mike, but there is for me. Like when I run passive houses through my certification, like the residential, I have a passive house PHPP for certification, which I use all the defaults, and then I have my real PHPP, the one that I think is really going to work, right? Because I know it doesn't work like that, right? And the nice thing about the PHPP is whenever I tried to energy model before, I felt way out of my depth because I didn't know what was going on in the background. And Mark will tell you, when he was in the class with me, I bugged the crap out of him because I asked a million questions. So you had to infer what it was doing by the outputs. And energy modeling is 25% science, 25% experience, 25% art, and 25% pure voodoo, right? And not knowing what voodoo is going in behind the black box makes it very difficult to have a real confidence in your results. My guess is that's probably why Mark has written his own programs for energy modeling, because you knew what was going in. And you knew you can trust what was going in to what was coming out. So, where do we go from here? My whole guiding philosophy of the success in my business has been to underpromise and overdeliver. If I think it's going to take a week, I tell them it's going to take 2. If I think it's going to cost $100,000, I tell them it's going to cost $120,000, right? Because if, let's say something costs $105,000, and I tell you it's 100, and then I come back, oh, it's 105. What? You went up 5,000. But if I tell you it's 120 and come back 105, you're really happy, right? It's the same number, just how you approach it. So, we're used to thinking like, pretty much everybody in this room hopefully is outside of this, but we're trapped as Americans in this box. And what we're not used to doing is really being creative and imaginative in the way that we deal with buildings, right? I'm talking detail. How do you make a detail so that when you get on the job site, Jim Bob and Juan can put it up without have you stand over their shoulder to make sure that they put all 3 lines of caulk exactly 3/8 of an inch apart and exactly a 1/2 inch around. You know, I mean, you can't make details like that. They don't work. In real life, they fall apart. It's got to be super simple. So, you know, everything from the detail to the concept has to be creative to be able to deliver it efficiently. We got to be very meticulous, right? We can't just like accept what's in the program. We got to question everything. We got to use our colleagues, right? I bounce ideas off of people all the time. I love the fact that I can send my projects in for pre-certification before construction and have a colleague challenge my assumptions. You know, when I send in pre-certification to PHI or to PHI US and they come back and they say, well, what about this? What about that? Have you thought about this? You know, that, I mean, it's a pain, but it's a good, right? Because it makes the project better. I can tell you for sure that my projects that have gone through the pre-certification process are better projects than the ones that haven't. You know, because of that ability to review. Now, personally, I would love it if there was a user group, because I'm not getting everything certified. I can't, right? So I've got, like, for example, I'm building a house, getting ready to build a house. We just signed a contract. It's almost a $2 million house. And according to PHPP, by certification, it thinks there's 18 people living in that house, right? So if with 18 people, there's no way you're going to certify it because your hot water load is just through the roof. Well, the reality is there's 6 people, and when you're 6 people, it's way under. So I can't send it in for certification. But I would love to have somebody look at my PHPP and see if I've screwed something up, because there's a lot of numbers that can go wrong. I've been through it up, down, middle, sideways. But so a users group would be great, trading them back and forth. So, you know, I guess to sum it up, you know, we have a huge opportunity. This is really exciting. There is a lot of potential to do really good stuff and really to change the way that we're building in this country. But there's a lot of room to screw it up too, okay? And I feel like if you're in this movement, then it's in your best interest to see that every single person's project is the very best project it can be, because one person's success is all our success, and one person's failure is all our failure. It's a small enough movement that we all own all of it, right? So if I don't know how many people saw the articles about the Belgian house that had the vapor drive and that house melted, the Passivhaus. I don't know how many people saw that, but you know, that kind of press in the United States is going to kill this movement, right? So we can't afford that. So as a group, we need to support each other so that we're able to really push ourselves forward as a group. Anybody have any questions? Yeah. Thank you.